Good day, students. On this clip, we're going to be going over some examples on how to use the sandwich or squeeze theorem to evaluate limits. All right. So before we start, we're going to go over some basic formulas that we're going to be using to solve more complex problems. So you recall what the squeeze theorem basically is. One special case of the squeeze theorem is the following limit. The limit as x approaches 0 of sine x over x equals 1. Okay, I have a tutorial that goes into detail as to how to derive this equation right here using the squeeze theorem. But we're just going to start off with this because the focus of this tutorial is on how to use this theorem to to find limits. All right. So by extension from this formula, there are also a list of formulas or tricks that we can also use. We can also keep in mind the following fact that the limit as x approaches 0 of sine ax over ax is equal to 1. Okay? Another way to look at it, you just basically divide the coefficients of the x's. All right? And then another formula to keep in mind is the limit as x approaches 0 of sine ax over bx equals a over b. In this case, it was a over a, that's why it became 1, all right? So these are some cool formulas you can keep in mind, and you can evaluate limits involving the squeeze theorem mentally. You don't even have to write anything down. Another limit to keep in mind, limit as x approaches 0 of sine ax over sine bx. Guess what this is? This is also a over b, all right? All right, so the main one I'm going to be using today is this one right here. So what you just have to keep in mind is as long as the argument of the sign and the denominator are identical, the limit as x approaches 0 of that quotient is going to be 1. All right? Okay, so let's take a look at some examples. I'll have you do them mentally, and I'll show you algebraically that your results are in fact correct. Okay? So example number 1, what is the limit as x approaches 0 of sine 3x over 2x over 2x. Okay? Um, take a look at this. What do you think the limit is? If you remember this from what I showed you right here, ax over bx, you can clearly see that this is going to be 3 over 2, okay? But this is not directly, you cannot directly apply the sandwich theorem here because the argument of sine, 3x, is different from the denominator. So we have to do some work here. Even though we know that the answer is 3 over 2, let me just show you that it is in fact 3 over 2. So the task is to get the argument of the sign identical with the denominator. So how do we do that? So what I'll do first is I'm going to take away this 2. I'm going to separate the denominator. We have limit as x approaches 0 of sine 3x over x, and then I'm going to put the 1/2 over here. Okay, so basically separate these 2 from the x. So the goal is to make this 2 identical. So how do I make these 2 identical? Well, I'll have to introduce a constant, right? Since this is 3x, I want this to be 3x, so I'll multiply the numerator and the denominator by 3. Okay? All right, so you have to be careful here when you're multiplying. So this becomes limit as x approaches 0 of, see this 3 comes to the front. It's not an argument, so 3 over 2 sine 3x over 3x. Okay? So basically move this number to the front. Let me give you an arrow to show you what I did. So this one goes to the front, and this goes right to the denominator right here. All right? Don't multiply this number. That's not correct. Okay, so remember that this 3x is our argument of sine, so you can touch it. So now, notice that these are identical. So this is what I wanted. This is always the goal, to get the argument of the sine and the denominator to be the same, okay? So I can factor out the 3 over 2, and then we're going to have the limit as x approaches 0. Remember, this is independent of the limit because it has no variable there, of sine 3x over 3x. And then you can say, make a substitution. You can say let u be 3x, and then you have sine u over u, and then you can apply the whole idea of limit laws. But this is sufficient right here. So for this is going to become 3 over 2 times 1 using the squeeze theorem, and your final answer is going to be 3 over 2. Isn't this the answer we figured out earlier without even doing any work? We could just tell that the answer was in fact 3 over 2. All right, so that's the beauty of knowing this theorem. All right, now let's take a look at another example. Number 2 was the limit as x approaches 0 of sine 5x over sine 2x. Okay, let's write that again, sine 2x. Now let's take a look at this limit. Just by examining it, you can automatically tell the answer is going to be 5 over 2. Remember a shortcut I showed you earlier? If you have sine x over sine bx, just divide the coefficients of x, that will give you the limit. So we know that the answer is 5 over 2, but let's show the work just to verify, okay? So how do I show that this is 5 over 2? Well, first thing I'll do is express the numerator and the denominator as a fraction, sine 5x over 1 divided by sine 2x over 1. Okay? The goal is to get the denominator and this term identical, and then this denominator and this term identical. So in the numerator, I'll multiply by, let's see, how about multiply by 5x top and bottom? 5x and 5x. And over here, how about I multiply by 2x top and bottom? 2x, 2x. Okay? All right, notice I'm going to order these terms right here. I'm going to have the limit as x approaches 0. The numerator, you will take the number or the number you multiplied by, the term you multiplied by, and place it in the front of the trig function, okay? Place that in the front, and then the bottom goes to the bottom. So we're going to have limit as x approaches 0 of 5x, and then we have sine 5x over that 5x I introduced, divided by 2x sine 2x over the 2x I introduced also. All right? So you notice that these two x's divide conveniently here. They divide out, and I can also factor them out. Okay? So now we're going to have, it's going to become 5 over 2. Now we can divide this limit into the top and the bottom. So we have the limit as x approaches 0 of sine 5x over 5x over the limit as x approaches 0 of sine 2x over 2x. All right? And then using the sandwich theorem, these are identical. We can call them whatever we want. We're going to have 5 over 2 times the numerator is 1, the denominator is 1, we multiply across 5 over 2. Isn't that the answer we came up with earlier? Yes, absolutely. So just by inspection and knowing your tricks, you can basically determine what those limits are just by inspection. Okay? All right, so now let's try some heavyweights, try some more complicated problems. This was number 2. Okay, let's take a look at question number 3. So for question 3, let's find the limit as x approaches 0 of 2 sine 10x. Okay, let me change this a little bit. Let's make it limit as x approaches 0 of sine 10x divided by 2 tan 3x. Okay, that's what I meant. All right, now you can clearly see that in this problem, we cannot use the sandwich theorem directly here. It's a little bit complicated. So we might have to make use of our trig identities, okay? So tan can be broken down using the quotient trig identity. This can be broken down into the limit as x approaches 0 of sine 10x divided by 2 sine 3x over cosine 3x. Okay? All right, so we can just factor out this 2 as a 1/2. So we have 1/2 of the limit as x approaches 0 of sine 10x we can multiply the numerator by the reciprocal of this fraction right here, times cosine 3x over sine 3x, right? Because when you divide by a fraction, it's the same thing as multiplying by its reciprocal. All right, and then let's see what we can do here. Now, what we can do next, I'll write it in a way that will be easy for you to tell the answer just by inspection. All right, so it's going to be limit as x approaches 0 of sine 10x over sine 3x cosine 3x. Okay, let's take a look at this. Can you tell what the limit is, this limit, just by looking at it? Well, you should be able to tell that this piece is going to be 10 over 3. Okay, using this trick I showed you up here, sine ax over sine bx, you just take you just divide take the quotient of the coefficient. So this is going to be 10 over 3. And this limit right here, if you plug in 0, cosine 0 is 1, so it's going to be 10 over 3 times 1, which is 10 over 3 times 1 half, which is going to be 5 over 3. So we can easily see that this limit right here is going to be 5/3. Okay? All right, let's go ahead and do it. Let's show our work, even though we know what the answer is. So this is going to be 1 half times the limit as x approaches 0 of sine 10x over 1. I'm going to express the numerator and the denominator as fractions because I'm about to introduce something that can make it possible to apply the squeeze theorem. So I need this to be a 10x, I need this to be a 3x. So in this side right here, I multiply top and bottom by 10x. And then here I multiply 3x. Okay. All right. Now let's rewrite it so it looks nice. So it's going to be 1 half times the limit as x approaches 0 of this 10 goes to the front. Remember, we're going to write it as 10x sine. All right, I will write it again. It's going to be, yeah, it was fine. Okay, it's going to be 10x sine 10x over 10x over, and then the denominator, the same process, 3x sine 3x over 3x. Okay? And then cosine 3x is not a problem, leave it alone. All right, now we can do some division here. Notice that its x's can divide out, so we have 10 over 3, so we can factor out the 10 over 3, and we can basically take the limit of all these three terms. All right, so let me show you all the steps, even though you can do this mentally. So you have 1 half times 10 over 3, okay? And then you're going to have the limit of the numerator as x approaches 0 of sine 10x over 10x. For the denominator, the same story. Is going to be the limit as x approaches 0 of sine 3x over 3x. And then the limit as x approaches 0 of cosine 3x. Let me make sure it's 3x. Yes, it is. Okay, now we're going to use the squeeze theorem. This 2 goes here, 1, 2 goes here, 5. This is 5/3 times, the numerator is going to be 1, the denominator is 1. Cosine of 3 times 0 is cosine of 0. Cosine of 0 is 1. Your final answer is 5/3. That's the answer that we knew earlier. All right, so there you have it. Okay, let's go ahead and try another example. So for number 4, we're going to find the limit as x approaches 0 of x to the 3 halves divided by sine square of root x. Okay? All right, so let's take a look at this for a minute. This looks a little bit complicated. Let's see if we can use some tools from the properties of exponents to rewrite this in such a way that we can apply the squeeze theorem. Okay? All right, so I can write this as, let's see, the limit as x approaches 0 of the square root of x raised to the 3rd power divided by, since we're squaring sine root x, we can write this as sine of root x multiplied by sine of root x. Okay? You see a pattern forming here? Let me write it out so that it's easy for you to tell. So we have a limit as x approaches 0 of square root of x over sine root x uh, times square root of x over sine root x. And you know what's left? Notice we have 3 root x's in the numerator, right? Because it's being raised to the third power. So we just put that on the side here, times root x. Okay? Alright, so it's looking better now. So now let's play some tricks with this numerator right here, see what we can do to make it possible to apply the squeeze theorem, and then we can finish this off. Alright? So if you want to make a wild guess, guess what? You can apply the squeeze theorem here also. This is going to be 1, this is going to be 1, square root of 0 is 0, so it's 1 times 1 times 0, so this limit is 0 just by inspection, but let me show you how to do it, okay? So we have limit as x approaches 0. I'm going to write the numerator as a fraction and the denominator as a fraction likewise, okay? If we don't put in the right formulation, we can't apply the squeeze theorem. We must be able to put in the right form, okay? So times the same on the numerator here, and then the denominator, same process. Okay, now, I like there to be rad x right here, so it matches the argument of the sine function. So what if I multiply the numerator and the denominator by 1 over root x? Okay, like that, and then multiply this by 1 over root x. Same story here, and that same thing here, okay? Let's not forget this guy, root x over here. It's not causing any problems. Put him on the side. Okay, now let's simplify this. You notice this square roots divide out, and then these two divide out. So now you're going to have the limit as x approaches 0 of 1 over sine root x over root x times 1 over sine root x over root x times root x. Okay? Now, if you take the limit of all these 3 terms, you can apply the squeeze theorem to these 2. So you're going to end up with 1 over that is going to be 1 times 1 over, using squeeze theorem here again, that will be 1 times, this limit is going to be square root of 0, which is just 0. Okay? So you're going to have 1 times 0, which is 0. And there goes your final answer. Okay, now let's try one last problem. For question number 5, we're going to look for the limit as x approaches 0 of 1 minus cosine 5x divided by 25x squared. We have a situation here, guys. There isn't any sign, so how on earth are we going to make use of the squeeze theorem? All the formulas should involve sign, and this is a cosine right here. So what are we going to do? Okay, so this is a case where we can actually make use of the squeeze theorem, believe it or not. I just have to do some tricks with some trig identities, and it'll fall into place, all right? So what I can do here is multiply, how about I multiply the numerator and the denominator by the conjugate of this expression. So 1 plus cosine 5x to the numerator, and then 1 plus cosine 5x in the denominator, all right? So if you multiply that out, this is the difference of squares, a minus b, a plus b. So this is simply the limit as x approaches 0 of 1 minus cosine square of 5x. Okay? Let me write it nicely. So if you don't understand what I just did here, you can multiply it out. You can multiply out the whole thing, and the 2 middle terms cancel out. But we don't wanna do that. We already know this. All right. So cosine square 5x. So I just follow this out. The middle terms cancel out. So you end up with this over 25x squared times 1 plus cosine 5x. Okay. Now let's shift our attention to the denominator. Using the Pythagorean identities, I can change this to sine square, right? thinking back to trig, so limit as x approaches 0, that becomes sine square 5x over 25x squared times 1 plus cosine 5x. Hopefully I didn't lose anybody here. Just remember that 1 minus cosine squared theta is equal to sine squared theta. Okay? That's what I did here. In this case, theta is 5x. Anyway, there you have it. So now let's break this down so we can make use of the squeeze theorem. Okay, so we have the limit as x approaches 0 of, let's see, sine 5x over, you know what? See the 25x, we could break it down, right? It's 5x times 5x. So 5x times sine 5x. Remember, sine squared 5x is sine 5x times sine 5x, right? Okay, over 5x. And then times this gentleman over here, which is 1 over 1 plus cosine 5x. Okay, now we can now make use of the squeeze theorem. So I can write this as this is x. All right, so using the squeeze theorem, this limit is going to be 1, this limit is going to be 1. Let me just show you so nobody gets confused here. So we have, we're going to do, well, limit as x approaches 0 of this one, sine 5x over 5x. This one's going to be 0. I mean, this one's going to be 1 times limit as x approaches 0 of sine 5x over 5x. This is going to be 1 also. Times this little guy over here, limit as x approaches 0 of 1 over 1 plus cosine 5x. Okay? All right, so this becomes, this limit is 1, this other limit times 1. And then in this case, I can just plug in 0 for the x here. So it's going to be 1 over 1 plus cosine 0. Because 5 times 0 is 0, right? Cosine 0 is 1. So it's going to be 1 over 1 plus 1, which is 1/2. All right? So there goes your final answer. So thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel by clicking up here. Please post a comment to let me know what you think about this clip. More clips can be found on mathguyserve.com. Thanks again and have a wonderful day.